We are live. There is always a little bit of delay at the beginning
Uh-huh.
when we are waiting for when I'm waiting for a confirmation from YouTube that it has started streaming. So all the people who might see us just waiting around for the initial
Right.
5-10 seconds, that's what's happening every time.
Sure.
All so welcome everyone. Happy New Year. Um, and we are going to continue with our sessions that we were having before the Christmas and New Year vacation. So we'll be talking about advanced SQL again. We have one last exercise left, so that's what we are going to do today. And we were just talking before going on live about topics for next week. Um we were thinking about either going with geospatial analysis or natural language processing. But if you guys have any other topics that you would like us to discuss, then please send in the comments or mail mail it to us so that we can concentrate on the topics that you guys are more interested in at the moment.
Mhm. Please do.
All right, with that, let me start my screen share. All right. And so again, it's a Kaggle exercise. If you if this is the first video you guys are seeing, I would suggest go back to some previous videos. I would My recommendation would be start with the introduction to SQL, cover all those videos, and then come to advanced SQL. And we already have had 3 videos for advanced SQL. This would be our fourth, and we are doing these exercises from kaggle.com. So if you go to kaggle.com, it will bring you to the Kaggle page. Go to courses, and inside courses, look for advanced SQL, and this is the one that we going to do today, writing efficient queries. So like every time, we are going to go through the exercise through the theory part of this exercise quickly, just so that we know what kind of practical questions we might have to answer later on. And plus it just gives us a nice I don't know, background information uh, about what we are going to be talking about. So writing efficient queries. Introduction, some useful functions: show amount of data scanned, shows the amount of data the query uses, and show time to run, prints how long it takes for the query to execute. All right, so this looks like we might, so when they say efficient, that means something, queries that are going to run faster. So that's where the show time to run is going to be useful. That way you can keep optimizing your query till the time you get the most efficient or or the fastest query possible. And that just builds up your skill for later on. So for example, if you star query, select star from BigQuery. If you choose show amount of data, I'm guessing it should be all the data set possible, right? Also the data processed, if you do search for everything, is like 2.5 terabytes.
It's a pretty fair bit.
I'm sorry, what?
That's a fair bit.
Yeah, that's a lot. And then there is this basic query where you select size comma binary from BigQuery.
So
So
just two
basically,
columns. Yeah.
yeah, rather than choosing all the columns, you're just choosing size and binary, and that
And just
just yeah,
remember, that's just the contents table too.
yeah, and it's the same table that you're using, but you're just choosing 2 columns rather than choosing all the columns, and that
Right.
decreases it by 1,000 times.
Mm-hmm.
All right, read less data. So both queries below calculate the average duration in seconds of one-way bike trips to the city of San Francisco. So more data query, select minimum of start station time, uh, min of end station time, average of duration second from this table. And in the less data query, you are selecting start station time, end state end station time, average duration second as average duration second. Where
Oh, I see. They're picking a name based on ID in the first one. The second one, they're just picking name directly or using name
oh
directly.
okay, yeah. So that would really limit. So since
Yes. You have
so since
fewer columns you're working with.
yeah. So rather than using just the columns that have been selected here, what they are doing is they're going through the entire data set and looking for it. Over here, you are already selected some a subset of the columns, and that's where you're doing all the processing or all your query work. Where rather than using start station ID, they are using start station name and end station name. All those things are already available in this mini table that you have created, and that decreases it by a bit, not much, but a bit for sure. So avoid n is to n joins. Most of the joins that you have executed in this course have been 1 is to 1 joins. In this case, each row in each table has at most one match in the other table. Another type of join is n is to 1 join.
Yeah, I think we might read that as many to one.
Yeah, many to 1 join. Here each row in one table matches but many rows in the other table.
Which has an intermediate table required too.
Yeah.
Or at least an intermediate ID.
So let's take a look at their example. Number of distinct committers and number of files in several GitHub repositories. So select repo, count distinct c.committer name as number of committers, and they do an inner join. Show time to run for this, and then the small join query, select count, distinct.
Oh, two completely separate subqueries and then do stuff with them.
Yeah. Yeah, they want to get as small a table as possible before they do any joins.
Right, and that makes sense. Do your limitations before you join. It'll
Yeah.
make the join faster.
Yeah.
Less stuff to work with.
And
And indeed,
that's a really big difference. So
that's quite a lot faster, yeah.
So that's like 21 minutes, some seconds to 4.5 seconds.
Yeah, that's what, like a 30 times speed up or something?
Yeah. Yeah. And especially if let's say you have to run this query every hour or so, or every 30 minutes.
No, 300 times speed up, sorry.
Yeah.
And yeah, if you have to run it every couple minutes, you're not getting it done.
Yeah. Yeah. I mean, every couple of minutes, the second one you will have to go with the second one because the first one is not going to complete in that 2-minute time frame. So that's where all these getting it to run faster is going to be helpful. This is going to be interesting.
All right, let's check it out.
All right, let's go into the exercises. All right, so like always, the first one is when you are setting up your notebook. It basically just involves some of the libraries. I think I need to log in first.
I say, how do you have night mode or dark mode?
Yeah, all right. I will stop sharing for a second before I sign in, and then I'll share again.
Yeah, I didn't know you could do dark mode on Dagger. That's interesting.
Yeah, I had no idea either.
That surprised you too. Maybe they're doing A/B testing or something.
No, actually, it's again in the normal.
Oh, okay.
All right, so let's start. So like I was mentioning, the first one is just basically having some libraries that aids us in the rest of the notebook. All the following cells where It provides you with possible solutions, hints, and all those things, and these are the libraries that take care of that. And this is something that you'll find in all the Kaggle exercises, where you'll have this first block that just does basically that. So you don't need to worry about that right now till the time you're actually building your own exercises on Kaggle. When you're building your own exercises, then you need to keep in mind that you need to have something like this already present so that you can give other people hint or solutions. All right, so you work for Pet Costumes International. You need to write 3 queries this afternoon. You have enough time to write working versions of all three, but only enough time to think about optimizing one of them. Which of these queries is most worth optimizing? All right. It looks like this is just basically looking at the question and seeing which one is worth optimizing. I don't think we have to write the query, at least for not for now. So a software engineer wrote an app for the shipping department to see what items need to be shipped and which aisle of the warehouse to go to for those items. She wants you to write the query. It will involve data that is stored in an orders table, a shipments table, and a warehouse location table. The employees in the shipping department will pull up this app on a tablet, hit refresh, and your query results will be shown in a nice interface so they can see what costumes to send where. The second scenario is the CEO wants a list of all customer reviews and complaints, which are conveniently stored in a single reviews table. Some of the reviews are really long because people love your pirate costumes for parrots and they can't stop writing about how cute they are. All right. Third scenario is dog owners are getting more protective than ever. So your engineering department has made costumes with embedded GPS trackers and wireless communication devices. They send the costumes coordinates to your database once a second. You then have a website where owners can find the location of their dogs or at least the costumes they have for these dogs.
Yeah.
For these, you need a query that shows the most recent location for all costumes owned by a given event. This will involve data in a costumes location table as well as a costumes owner table. So which one do we think?
Well, there are a lot of dog owners,
Yeah.
and once a second is a lot of data. So we're
Yeah.
talking 264-bit floats, right? Every second or something like that. And then the timestamp too, and the person. So that adds up real fast.
Yeah. The thing
Number
is though, that
two,
in the dog owners, it's you would your query would need to run when a dog owner pulls up the website to find out the recent location.
right? So we would ideally need to know how many times a second, how often that's going to happen.
Yeah.
Number two sounds like a one-off. I mean, that's just make
Yeah.
this thing and send it to me, and it's like, okay, that's easy.
Yeah. The second one definitely it doesn't look like it doesn't sound like something for which you need to optimize. Unless and until your CEO wants it.
Every second, right?
Yeah. Every half an hour, as soon as he gets one report, he's like, give me the second report.
Right. And then what about the first one though? That involves data from 3 different tables.
And that also looks like something that would be an ongoing process every time. So for me,
Yeah, how many people do we have in shipping?
so the first
Right.
one does sound like the one that is in the most urgent need for optimization. Because I think shipping is something that will happen a lot more frequently.
Mhm.
And people are going to be ordering things, and then whoever is the person with the tablet, they are going to be running that query again and again.
Right. So either 1 or 3, we think, right? Definitely not 2.
Definitely not.
Okay.
So I think one might be the way to go. Let's start with one and we'll see.
I'm thinking 3, but we'll see. Let's find out. Ah.
All right.
I mean, that was a good choice. It really depends on. I mean, we really need a lot more information to give
Yeah.
a ballpark answer.
Three
We've
is
got. I mean, there's tens of millions of dog owners in the country. So, and he's pulling down data for dogs every second. I mean, we're talking in a year trillions of data points easily. So,
Yeah.
That was why I thought that one.
All right.
And
So
it has to filter through all of them, right? Unless you're indexing by human and time or something. Anyway, got it.
All right. So 3, because data is sent to each, like you mentioned, at each second. So that's going to be the most data, and it will be run on a recurring basis. So writing this well could pay off on a recurring basis. Why not 1? This is the second most valuable query to optimize. It will be run on a recurring basis, and it involves merges, which is commonly a place where you can make your queries more efficient. And second, all the reasons that we gave, that it seems like a one-time run, and a few extra seconds is not going to cost anything. So 3, you were right, just because of so many data points, that this one, they say the third. And they do give the reason which I had for 1 as well. So, but yeah, it does look like it's not going to be every second. So it's not going to be it's not going to be needed as much. And GPS location changes a lot.
Oh no, they're storing it. They're storing it as a string. I'm scared now.
Yeah.
Oh boy.
All right. So make it easier to find Mitzi. What is Mitzi?
I guess that's one of the dogs. Maybe.
So you have the following 2 tables. Yeah. So timestamp and location and costume owners. So the costume locations table shows timestamp GPS data for all of the pet costumes in the database, where costume ID is a unique identifier for each costume. Yeah, I think we have that. So these are the 2 common columns where we'll perform the merge. And all right. So you need to use these tables to get the current location of one pet in particular. Mitzi, the dog. Uh, is there a way to make this faster or cheaper? Do we need to write something?
I think they're just asking that direct question. Is there a way to optimize it?
So let's see. What are
Let's
the
analyze. I think something. Oh, there you go.
All right. So with location and owners as select star from costume owners, CO inner join costume location C1 on CO.costume ID equal to C1.costume ID. Last seen as select costume ID max timestamp from location and owners. Group by costume ID. Select.
Oh, they're joining the table first.
Yeah.
Before they do anything else. That's it. We already saw that. That's going to cost you.
So that would be my first optimization. That first have a condition, where you are using Mitzi's ID or the proper costume ID, and that way you are going to reduce the number of columns over here. So you're not merging everything and then looking for this first costume ID, and then you are and then you find the maximum ID. So this merge is going to be expensive, or join is going to be expensive. So that would be the first thing, and that should bring down the cost a lot.
I would think so. Yeah, and you can crunch down both tables because you know the dog and you know the owner. So.
That's true. So,
or at least the owner anyway. See, yeah.
Yeah. So where owner ID equal to Mitzi owner ID. So rather than having this condition over here, you can have this condition on both of them. So on both costume owners and costume locations.
Do we have a? Well, I think. Well, wait. So do we have a Mitzi's ID or no? Maybe. I guess we don't.
Yeah. So in this example,
you just have the owner ID, right?
Yeah. So there is a Mitzi owner ID.
Yeah. So you want to limit that first table first.
Actually, we both table. So yeah, first limit this table first.
Or sorry, limit the second table first, because you have the owner ID, and that gets you a list of costume IDs. Maybe just one for mid-season.
Oh yeah. So one of mids is owner. So
And then you pull that one out, and then you can limit the second one,
yeah.
or at least limit it to the selection, and then grab most recent result from.
Yeah.
At least that's my thought.
Yeah. So they are minimizing this costume ID first.
Mm-hmm.
Oh, sorry, costume owners first,
Mhm.
and
Yeah, and then extracting that costume or the list of costume IDs and finding all the ones in there.
yeah.
Yeah. So that's a
And
fair
so
improvement.
instead of doing large merges and running calculations.
Right. So if you say you have a trillion or a million dogs and a million owners, right? Instead of searching through a million times a million by interjoining first, you limit one table down to 2 or something, and now you do 2 interjoin a million, and it's
It's going to be faster.
500,000 times faster. So.
Yeah, I agree. So yeah, I mean that's basically it. It doesn't look like we had to write any queries.
Oh well, that was okay.
That was interesting. All right.
Nice and snappy,
All
I
right.
guess.
Yeah, I mean, so for the people who are watching, if you guys have any of these inner joins that you want to perform or something, it's always best to minimize the table to the smallest form possible. And that depends. I mean, you need to keep an eye out on like if you have 100 into one table with 100 entries and another table with 5 entries, changing that 5 to 4 uh, might not make it as much faster than the extra work that you're putting in. So it has to be how large the data sets are. Like William mentioned, that's a definite improvement. The case of a million and million, where you have to perform joins on them. That's a big improvement. So you definitely want, in that cases you have to optimize. But if it's a very small table and and the development time that it's going to take to actually make your query more efficient, and you'll have to just weigh both of those things out and uh, and go according to that. But that brings us to the end of advanced SQL. I hope you found both of these exercises from Kaggle, the Intro to SQL and Advanced SQL, informative. I really found it useful, especially all the work with the BigQuery, because BigQuery is gaining some steam as well now. So having some experience with this would be really useful.
And certainly SQL is becoming much more popular as a data storage medium across a lot of data science related fields that data science touches, essentially.
Yeah.
So having knowledge of it is helpful no matter where you go at this point and in the near future.
Like we have already mentioned a few times that it's basically pandas tables and everything are really helpful, but in most of the organizations, when you are actually looking through large data sets through which you have to do data analysis and stuff, there is a really good chance that they have a database sitting on their servers. That's where you are going to get the data from. So having some, I guess, familiarity with how you can go about getting those data and how you can get queries and all those things done with SQL, I think that would be useful.
And if you think about it, right, think about a data frame. If you had a million owners and a million dogs, or in a million, what do you call it, entries in that first table for each dog, your data frame has to have all of that data. So you're going to have a lot of repetition. You can't get away from that in a data frame. With a database, though, you can do these normalizations where you extract common information into a separate table.
Yeah.
And that will save you a lot of space. And that's why it's becoming so popular, is because there's so much data, we have to find ways to store it more efficiently. And so everybody's jumping on the SQL wagon, so to speak.
Yeah, and pandas does become a bit slower once the entries start. I mean, that's the case with databases as well. And just databases are generally more optimized. So
But we're not saying get rid of pandas, right?
yes,
Because
definitely. Yeah, yeah.
you want to know SQL to get the data you care about out, and then use something like pandas to do your calculations on and your visualizations and stuff.
Yeah, that's definitely not the message we are trying to send, that get rid of
Right.
pandas and
They
just
both have their place. They're just two different tools used for the right. Yeah. And you can use both.
All right. So this is it from our side for today. I mean, we just wanted to finish this advanced SQL and not leave it hanging. And next week, like I mentioned before we went into the exercises, that we'll be talking about either natural language processing or geospatial analysis. If you guys have any preference, let us know. If you want us to discuss some other topic, then let us know. And otherwise, I will see you guys next week.
Yep. Thanks for joining us.
Thanks.